Good day everyone, especially to Ma'am Alma Patria. I am Aliyah K.D. Cuajotor, and for today's activity, the activity 7 entitled Titrations.
So we have 3 objectives. The first one is to know what is titration. The second is to identify the different types of titrations. And the last one is to quantify acid and base reactions by titrations. What is titration? Titration is a process of chemical analysis in which the quantity of some constituent of a sample is determined by adding to the measured sample an exactly known quantity of other substance with which the desired constituent reacts in a definite, known proportion. So let us go to the 4 types of titration. First is the acid-base titration. Second is redox titrations. Third is precipitation titrations. And the last is complex symmetric titrations. First is acid-base titrations. An acid-base titration is a quantitative analysis of acids and bases. Through this process, an acid or base of known concentration neutralizes an acid or base of unknown concentration. Second is the redox titrations. A redox titration is a titration in which the analyte and titrant react through an oxidation-reduction reactions. As in acid-base titrations, the endpoint of a redox titrations is often detected using an indicator. The third one is precipitation titration. Precipitation titration is a type of titration which involves the formation of precipitate during the titration technique. In precipitation titration, the titrant reacts with analyte and forms an insoluble substance called precipitate. It continues till the last amount of analyte is consumed. And the last type of titration is complex symmetric titrations. Complex symmetric titration, or sometimes chilatometry, is a form of volumetric analysis in which the formation of a colored complex is used to indicate the endpoint of a titration. Complex symmetric titrations are particularly useful for the determination of a mixture of different metal ions in solution.
This time, we're going to talk about quantifying acid and base reactions by titration. One famous laboratory method is titration. Chemists use this method to quantify the unknown concentration of the solution by acting it with solution of known concentration in acid-base titration. The acid may be the solution with known concentration and reacts with a base of unknown concentration to determine his concentration or vice versa. So declaration is done just like this. Suppose you have unknown concentration of sodium hydroxide and you want to determine the unknown concentration of HCl. So you do the equation to put the HCl solution of volume 50 ml in an Erlenmeyer flask and you fill the beads with sodium hydroxide solution up to the 0 mark. You need an indicator code of naphthalene and put 3 drops to the Erlenmeyer flask. The purpose of this indicator is for us to know the endpoint. Now, you start your declaration several times later. You notice that there is a temporary color link like pink change when the sodium hydroxide solution drops. This means that we are now going to reach the endpoint. The endpoint is a permanent color change from colorless to light pink. When you put more sodium hydroxide exceeding the needed sodium hydroxide for the endpoint, then your solution is now overrun. Another term used in titrations is equivalence point. This is the time when the amount more H plus ions has reacted with the same amount of voice minus ions. This appears as the temporary color change in your titration, whereas endpoint has slightly excessive amount minus and appears as permanent color change in your titration. You can learn more titration techniques when you have your actual titration. Actually, in reality, we cannot tell when or where the equivalence point. So we need to reach the end point, and the volume of sodium hydroxide juice is what we use in our calculation. So here, we assume the demand mole of sodium hydroxide from the end point is equal to the amount more sodium hydroxide to equivalence for us to solve the unknown HCl concentration. So my generalization is titration is important not just in chemistry classes. It has numerous uses in everyday life, making it a valuable analytical tool and quality control test. To acquire an accurate result in titration, we must be clean, attentive, and mindful of the apparatuses we will use and the procedures we will follow. So that's the end of my video. Thank you and God bless.